Hi, I'm Sportster Paul. We're here with SolidWorks CAM. We're going to look at test part that was made by a buddy in California. It's made to be hard for this automatic feature recognition the sophisticated CAM programs claim they can do. This SolidWorks CAM is free 2018 later. This is a 2020. You can upgrade to a SolidWorks CAM Professional. Then you get a perpetual license, at least I told you are. And then you can go to CAMWorks, who makes all this stuff. CAMWorks Mill is a full 3D package. This is 2.5D. So this is the part it took episode 1. This is episode 3. Episode 1, we fixed these pockets. The automatic recognition botched that up. It went halfway up on one. It didn't know how to deal with these breakout holes. I had to do a sketch to get the tool to follow past these holes. There may be a better way. I'm a non-machinist and I'm brand new at this stuff. So it's just my journey trying to learn this program. Last episode, episode 2, was these 5 holes. Automatic feature recognition, when Dave tried it, it does these 2 holes from the top and then the 3 remaining holes on the bottom, which is the last way you'd ever do it. You want to do all the holes at once. When I did automatic this morning, I tried, hey, let's see what happens if I can limit it, only recognize holes when you go Tools, SolidWorks CAM, Options. I got to open and close stuff off screen or the dialog box disappears. Sorry, I got a 1200 monitor, so the bottom of these boxes is cut off. It's smart enough to size it to the monitor, but I'm making a 1080 tall. Oh well. So here, this is general, mill features. See, oh, this dialog box dizzy, good gosh, I just turned everything off but holes, non-holes. You got to wonder what that means. And did that. So I'll drag this off and cancel it. And then this was goofy. In the feature tab, these are the 3 tabs, features, operations, tools. The features tab, where you're supposed to do this stuff, I tried, no, it won't do it here. I'm sorry, I'm in the wrong place anyway. Bottom, recognize local features. You try that and it says, well, no face selected. So you select this face, try local features. Oh, no features, can't do it. So I don't even know what that means. Obviously, I should probably read up a little more on this thing. But it was smart enough when I said recognize features here by right-clicking the bottom setup. It added the 5 holes just on the bottom. It didn't do 2 on the top and 2 on the bottom. So that's good. Unfortunately, it didn't do all 5 in one group like when I did it by hand. It did 2 of them, did 2 separate holes, hole 1, hole 2, and then whole group with the 3 remaining holes. If I remember right, it did the 2 through holes here separate, and then the others were remaining. That causes all kinds of problems because when you generate the operation plan, where is it? Generate operation plan, you go here to the operation tree. It's got center drill, drill, tap for the first hole, center drill, drill, tap for the second hole, center drill, drill, tap for the group of 3. To their credit, you can, in here, you can open them up and drag them all so you end up like here with 1 center operation, 1 drill operation, and 1, you're not changing tools constantly. There's another place in here where you can sort by tool order and all that goofy stuff, but I'd just rather have it right up front so I know what's going on. So it turned out, no, it took a half hour. The big mistake there was do not select the faces of the holes. Then it split 1 out or 2 out, depending on which time I tried it, and made a metric tap out of it. The trick there was when you're doing the holes manually, select the edge of the hole, and then it finally got us here. So this is the way the part was at the end of episode 2. We know what to do now. Save as, which should be called rename. Save and open. Now we're going to call this episode 3. Ooh, come on. Episode 3. Hopefully this will be, we did a bunch of takes here too. Episode 3, save. What does it want to do with the original? Well, I want the original document, close it, because I don't want that there. Then, always important, especially if you don't have, I got this stretched out usually, but to make these videos, hover over this. Is this really what I think I'm writing to? Because when I started this once just a few minutes ago, I had to retake it because somehow this part got saved. Oh, what a mess. But don't install PLM, Product Lifecycle Maintenance. That's a rootkit virus. Anyway, here we are, ready to start. What do we got to do? Let's go. Oh, I took the ribbon off because it was cutting the dialog box here, Enable Command Manager. This is this goofy ribbon like Word used to, 20 years ago everybody hated. If you say extract machinable features, it will go nuts and put in all those wrong features on top of the ones you already changed. Never hit this button. Generate operation plan might cause problems too. That's why I figured there are good things here, although it's broken here. For some reason, there's more commands here, but they don't show up when it's narrowed down like this. I just decided we're experienced enough now after 4 or 5 sessions with this. Let's get the vertical space here, not just to see the part, but the dialog boxes work out better. Let's go into Feature tab. Here's the part. Let's go into Feature tab. What do we want to do? Well, I'll show you first. See, now I went up to that non-existent ribbon. No, you got to be in the middle tab. So easy to get confused. Simulate toolpath. I made sure pause on collision, pause when the shank of the tool hits, pause when the tool holder crashes. Do it. It's done. See how quick that was? That's because I didn't go move at a time. If you go single moves, then it does animations, but we don't need that. Let's go quick, go end, and then the trick is you got to know to hit show difference. And all the blue means we haven't cut that yet. See these slopes, this flat plate, that's today's job. Let's see if we can pull this off. So get out of here. I learned there's a difference. So we're going to add, let's close the bottom setup. We want to do a perimeter. We want to do it from the top. It's in the vise, held the stock. I adjusted the stock so there's plenty of meat down here to hold in the vise. So I learned there's a difference between right-clicking on a setup where you're allowed to say, see, once again, wrong place. So many ways to get confused. If you set top setup, it says part perimeter feature. If you're saying, oh no, I want this to go at the end of this, part perimeter disappears. So I've learned part perimeter feature. It's acting smarter. When it automatically does it, it would machine all the way down to the vise, through the vise, to the bottom of the stock. I played around with this. I thought, oh, volume mill, that's a cool thing. It says high-speed machining, adaptive machining. Eye machining is what Solid CAM calls it. Constant tool load, so it really rips. I couldn't. Just leave it rough finish for now. This is nice. It tells you it's going to use a rough mill. For some reason, this is the technology database making your decisions. I think because there's not that much stock to remove, it's saying, oh, let's use a 1/4 inch end mill for the rough and a 1/4 inch for the clearance or the contour. Also, I would call finish. Well, okay. Then they're smart enough now, doing it by hand, it goes to the bottom of the part. Well, actually, I want to go blind, 1.1. I want to go, let's say, 20 thousandths more. Because you don't want to stop mathematically at the bottom, because then when we flip this over in the vise and go to face off this chunk here, it'll be mathematical where the one facing stops and the perimeter, and you might have a wicked sharp chop your fingers up edge. So let's go down 20 thousandths extra. You can watch this blue line hop when I take focus off of that box. Watch, bing, see, just did that little bit. You can probably see it, right? So that's a good thing to do. So it's kind of acting in the feature tab the way we want. We say, okay, go here, say generate operation plan. It automatically jumps us over to the middle tabs so it confuse you. Here's the roughing, here's this. Go here and here because I took that ribbon out. So now I just say generate toolpath like that. Looks pretty good. What bothers me is it looks like this end mill is coming down on the edge of the stock. There's the stock, right? I'm not sure if this box is as big as a 1/4 inch end mill. So there's lead out and lead stuff. I looked, I'm getting confused. There's so many dialog boxes. I'm sure there's a way to move it so when this end mill comes down to begin, it's not carving through the corner. I'd rather have it come down in air and then enter into the corner just to be safe. So there we are. We can, now because it's goofy, right? And here's another weird thing. It added this flat end mill. I thought maybe because the flute lengths were different, but it already had a flat end mill. And near as I can tell, they're identical. 1/4 end mill, the lengths all seem to be the same. Not sure why. So I figured, well, let's put all these in this 1/4 inch end mill. How different can they be? Where'd the first one go? Did it disappear? Tool 17, right? There it is. Pretty sad you got to remember stuff by numbers. All right. So there we are. Now, let's look at this out and this out. Well, they're using this flat one to hog the quick rough machining on the inside. So rather than doing a 1/4 inch here and here, is less tool deflection, less problems. Let's drag that. Magnificent, right? This is when you learn to love this program. Look, it automatically adjusted everything. Even though when I go back here, I always like to say, no, don't generate the operation. I see wrong tab again. Generate toolpath, just so it's doing everything. So now if you do here, simulate toolpath, go to the end, it crashed. See, this is why you click all these buttons before you send it to the mill. You have to click the first button. The tricky thing there is if you forget to put the facing is in the wrong order, like I had it once, it'll be crashing those center drills right down through the stock. So that has to be on as you work. What I did is I turned these two on, stop this, which is if the shank hits, and that's what's going on here. See, there's only 1 inch of flutes. You're not supposed to run the shank up against the side of the part as it's spinning. A chip will get in there. You need clearance. Some tools, they cut that shank part down to get away with this. Others, you can use longer flutes, or you should use longer flutes. Maybe some people try it. I just know it's bad practice. So not too hard. You don't want to do it individual operation, I find. Let's just go here to this 1/2 inch end mill, double click on it, flute length, 0.5, and this is when the program's so nice. See, it shows you. Since we made that a 1/2 inch longer, we need room for the collet. Let's make the tool itself 1/2 inch longer. Boom. So, nice, right? This box opens and closes on the same monitor. Amazing. So that solves that problem. I can show you. Do you care? Middle tab, simulate toolpath, do your thing. See, didn't crash now because the flutes are long enough that the spinning shank part, the smooth shank of that tool, doesn't hit the stock as it goes. Okay, happy days. Now we want to do this slot and we want to do this flat. I learned don't do the slanted part first because it generates a crash as the ball mill gets in the way of this big flat area. And I tried, you'll see the things I tried. Once again, I could not get this thing. If you call this a pocket, then it leaves material because it can't get the end mill in the corner of a pocket. It doesn't know to overshoot. There may well be some way to say, I tried open pocket, I tried, and I ended up going back to Klugetown, which is highlight this, start a sketch, get the rectangle sketch tool, go over that part, make a rectangle bigger than this face, escape to get out of the command, highlight that point again and make it not coincident because it won't let you move. Now it allows you to grab this and move it over a little. Say, okay, we're done with the sketch. Then I always like to name stuff. CAM, Kluge, sketch, forgetting how to spell, 2. That's our second. Then the other thing, I'll save you the grief of just hide it because you'll be able to pick it even though it's hidden. Come back here. Now, once again, we want to go underneath the perimeter. I don't know. It doesn't really matter. But let's do this afterwards. Our 2.5 axis feature. Let's make it a pocket. Make a pocket based on CAM, sketch, kludge, end condition. It wants to go down. It loves this 0.3937. That's how deep it was trying to make the holes. We had to correct it to 3.8. I don't know where it gets that, but something in this must measure that, and it goes crazy. It's trying to go down into the model, which you think it would be smart enough. Not a big deal. You know, let's not get upset. Up to face, here, bang. Just what you want. Rough, rest, finish. So the rest machining means it uses a big tool. So look at this. It's going to see. I wish there was a way. How do I change this tool here? It goes to the tech database. It's recognized this is an 86 kind of operation. I'd like to 86 this whole tech database. But I don't. You know, I understand it's cool for like a shop owner, right? But for a one-man outfit, I don't need the tech database. I am the tech database. So we're going to want to change that. Then it roughs the places where that big end mill couldn't get in the corners, which really doesn't apply here. Then it uses that end mill, and then it contours. So that's cool. We could do a rough finish. Yeah, let's do that. Let's do rough finish. It roughs with that. It finishes with a 1/4 inch. Okay. Say okay. Generate operation plan. Here's the rough. Here's the contours. So there's only 2 end mills instead of 3. All that's, that doesn't upset me or worry me. Then same deal. We don't want to use a, where is that big end mill? Here it is. We don't want to use that. Let's use it, make a 1/2 inch. Automatically the toolpaths adjust. I can see I might have a problem. No, when it finishes. See, the fact that the center of that big roughing mill, is it doing the rough? Oh, no, the contour was still here. When it does the contour, it's going to get past, although it's pretty wicked close here. When the center of the end mill goes there, that means, it's going to get this edge and get this edge. It really should make that a little bigger for that roughing mill, because it's going to leave a little hook here. But we're in a hurry. We're just trying to show you the principles. So where do we go? I think, are we there? Generate the whole toolpath. Simulate the toolpath. Bink. There you go. Even here you can see it. See, but this is what's so dangerous. You think, oh, it's simulated. Well, not until you do that. Now you can see what's going on. All right, left that. We're hauling now. See, just because I'm so frustrated with the automatic stuff, there's still a program now that I'm learning all its weirdnesses and quirks. It's still an amazing program, and this simulation capability, doing a Boolean subtraction, actually showing you, animating if you want to watch that tool go real slow. That's a big deal for a new person like me, non-machinist, right? I'm an engineer. So what's next? We want to do these slots. Once again, a lot of suffering. We're obviously going to do it from the top. So we say contour mill. Here it lets you, I think, do it either way. No, because we want to make a feature. You're allowed to do a multi-surface feature here, or you're allowed to do a multi-surface feature there. I'd rather go down here just to feel safe. Faces or surfaces, that one and that one. Area clearance Z level. It doesn't, this, if you do it, oh, technology database doesn't know what that is. Why'd you give me the choice? Fine, technology database wouldn't know what to do with this. So let's go back. No, that's not the one. See how easy it is to get twisted around. It's going to clearance with that 3/4 inch end mill, and it's going to Z level with a ball nose, which is, okay, now we're feeling comfortable. This is it. Every operation has a different pattern to it, a different set of dialog boxes. You generate the operation plan, you highlight the area clearance, you highlight and then, so you can say generate toolpath. Watch this fiasco. So there's a Z level. That's kind of what you want. Oh boy, look, it's carving these scallops. It's rastering across the angled surfaces with a ball nose end mill. Look at area clearance. It's like it machines through the floor of the part. And I think the intent of area clearance I have no idea. And I tried, is a setting? Because at first I didn't do that flat part separate with a little box and do it. I said, no, area clearance. Isn't that what that means? You clear out that flat spot so then you can run the ball nose. No, give up. So area clearance, the way to solve this is, where are we? No, you don't do it up here, because you can't change area clearance here. You go here, say area clearance, and you delete it. Yes, passive aggressive. You recycle bin, empty. Yes, passive aggressive. Here, I guess you can understand, because you can't get it out of if you take it out of the recycle bin, that's it. Middle tab, generate toolpaths. I don't know why I do this. It's like a superstition more than anything else. Then say simulate. Go right to the end, quick. Still pretty quick, you notice. It leaves these little scallops here. you know, the little scallop's going down, leaves a big scallop here, and I'll show you why the tool has to do that. This is where you'd use what they call a pencil mill to go in and just a real tiny 1/8, 1/16 and just get this sharp corner here. But okay, I'll trust that. But it's still not what we want. It's not fine enough, right? It's a little too coarse. I mean, it's in an automatic machine. We do this last, right? Yeah, we do the big thing first so it doesn't crash. I've been there on all my practice runs this morning. What do? We just double click on this. And because of my dialog box problem, everything has to open off screen. Let me get this out of more. Lots of messing around with this because it's kind of an, I don't know. They didn't plan for this. It's got its own little tab now, Z level. Down here is the operative thing. Let's add 10 times more scallops. So the depth parameter, the cut amount isn't 50 thousandths, it's 5 thousandths. Here's a tricky preview. Watch. Bam! Oh, cool. Now the box hasn't gone away. It's gone up here and hid. Oh, yeah, that's going to make a beautiful surface. Maybe 5 thousandths was ridiculous, right? Maybe 10 thousandths would be enough. But the finer you make it, the closer those surfaces will be to mathematically perfect. Now, the other problem, it left, if we simulate it, you'll see it lit up here. For that one, watch, let's see if it works. Oh, it opened. This was entry and retract. I just want to lengthen this one side. I found no way to do it. The solution, this is lead out. If you watch this dashed green line, it goes here. So it goes down and across and up. So you could say lead out radius, we'll make it much bigger. That might solve this problem. 3. And preview it again. Yeah, see how much fatter this radius? So I'm hoping that material that it leaves here, this part is brilliant. My buddy Dave did a brilliant job finding what screws up CAM programs. Took him 10 minutes to make this part less. Then I had the problem of, oh, well, this, let's show you. This ball mill, you know, if it's coming down right here, stepping over, and you can see over here, it rapids down to there. I don't like the looks of that. So at first, entry, retract, oh, this is where we were. I think lead in, lead out. I changed those. Well, let's do it for you. No, these are radiuses. So easy to get confused. Maybe this was NC, top of stock. I thought it was here. Oh, no, I'm sorry. Because they help you. Watch how brilliant this is. Lead in radius as you go in. Lead out radius. The arrow goes away. Here, it's how long these are. So you can increase these, which I did. It turned out, I said, you know, the other way to solve this is just make the lead in radius 0.3 as well. Preview. So now, burying this thing. So now when that ball mill comes down, it's down without hitting material, and then it goes across. And it's only going across 5,000 step. So I'm not worried about any kind of problems with that. So, see now you click, click, click. Oh, some tabs open, some won't. Okay. Now don't hit this like I always do and forget. I got to drag it off screen or it won't open again on the screen I can see. Say OK. Toolpaths, yes, absolutely. Middle tab, generate toolpaths over again because I'm paranoid. Middle tab, simulate toolpath, go to the end. Takes a lot longer because it's doing all of that. And there we go, we're done. I mean, I could get a pencil mill and show that. I just wanted you to get the feel for this thing. Do this. There's our little gizmo. And I think, let me see. Does this work? Does normal work? Yes. Times you gotta love SolidWorks. Make it about this big. Something's still going, normal. And of course, it defaults to its full view. I'm trying to make this step as big as this tab. Okay, silly as that sounds. I found out you hold control key. I've been trying to zoom in SolidWorks for a year. So, no, that's too big. Let's go right here. right? So it's about as big as the tab. So we'll do this, then we'll get out of the simulation. We'll double click on that Z level thing again. It's open and off screen. We'll select tool. I'm going to drag it off screen just because there's not room. And see, this is why it leaves that big thing. Now, you and me say, hey, couldn't you do that? And I assume there's a way to do that with 20 years of reading and a computer science degree. So that's a good thing to know. Cancel out of this. So there we go. There's the part. Still could use a pencil mill. Also, I can't use all these tools, right? I got a manual tool changer, these fingers, right? So I don't have rigid tapping. I don't have an encoder on my spindle, on my Avid benchtop Tro, fantastic little thing. So I got to mill these 1/4 inch holes because my spindle speed at 8,000 RPM is too fast to use a 1/4 inch drill. I could probably get away with an 1/8 inch drill. I bought some cobalts. We'll play around in my Home Depot aluminum, see what kind of speeds and feeds and how we can do that. But that's kind of stick a fork in it. Next episode, we're not done yet until I show speeds and feeds, things like that. I found some great resources. That HSM advisor fellow, he does an online calculator that'll kind of check. You can go to any of these, rough mill, double click, opens off screen because of my goofy problem. You do FS, which stands for feeds and speeds. Gosh forbid it's hard to read for you. But if you just go to operation now, it's saying, hey, put in anything you want. Here's another reason you go to the units tab of the drawing in SolidWorks options, not CAM options, but the SolidWorks options, and then go document properties stuff and go to units and make it 4 digits like all my machinist buddies like, because you're going to want to see exactly the feed per tooth, because it is thousandths per tooth swipe where you're allowed, most small end mills and stuff. The feed rate, 64. The most my machine will do is 200. It's doing 1,200. So we're going to mess with the speeds and feeds and kind of do a sanity check. We'll mess around with... Okay, so we'll mess around with the speeds and the feeds. We'll see what they guessed with their technology database versus what the HSM Advisor online calculator tells us, versus what Destiny Tool in San Jose, who I have no relationship. I mean, I just heard about him in a forum, asked my buddies, like, oh yeah, they used to be on Aldo, now they're in Morgan Hill. He thinks the world of them. They got some of these Viper end mills that they say, oh, surface feet per minute, fast as a spindle will go. If you're aggressive, conservative, they're like 1,400 feet per minute. So we'll get into that. I'll show you how to adjust it, how to set the part zeros. That's critical, right? How do you find zero? How do you know the G code matches where the part is in your vise? So that'll be the next episode. Meanwhile, good luck with your CAM projects. Have a lot of fun, and we'll see you all next time, all right? Bye now.